All right, guys. So welcome to page 9 and 10 of the notes. The first time you guys are seeing actually notes from this unit. What I did was I separated the 2 pages into 6 so that I could show my work and show you my steps and everything. So there will be a total of 3 videos for these notes. Part 1 will be the first 2 pages. Part 2 will be the next 2. Part 3 will be the last 2. So let's go over these notes. All right, so let's start off with geometric mean. What this is saying is that suppose you have 3 variables, A, X, and D, and all of these numbers are going to be positive. They're going to be 0 or larger. You see no negative numbers. And what it says is, let's say you have a proportion such that A over X equals X over D, then X is going to be called the geometric mean. And the geometric mean is going to be between A and D. So X is called the geometric mean between those 2 numbers, A and D. So let's say we want to solve this proportion for the variable X. Now, the first thing we're going to do is we're going to cross multiply. So we get X squared equals A times B. Then the next step is we'll be taking the square root of both sides. So we'll have the square root of X squared equals the square root of A times B. And after you simplify, you get X equals the square root of A times D. So the geometric mean is going to be a positive number always. It's never going to be negative. So let's do some practice problems with the geometric mean. So we need to find the geometric mean between 15 and 3. Now we have 2 numbers, so it doesn't matter where the numbers go. We can write it 15 over X equals X over 3. Or you can write it 3 over X equals X over 15. When you cross multiply it, you're going to get the same answer. So it doesn't matter where the numbers go. Let me erase this. And let's solve this. So we're going to get X squared equals 45. We're going to take the square root of both sides. I'll get the square root of X squared equals the square root of 45. So X equals the square root of 45. So this is not our final answer because we can simplify the radical. I think we practiced this back in unit 1, maybe unit 2. But the idea is we're going to simplify the 45 to its lowest terms. So X is going to equal the square root of 9 times the square root of 5. Now we can simplify that more. So we get X equals 3 times the square root of 5. Now that's your final answer for the geometric mean between 15 and 3. Now if I do number 2, the geometric mean between 9 and 8, let's do 8 over X equals X over 9. We're going to cross multiply. So we get X squared equals 72. Take the square root of both sides. And we get X equals the square root of 72. And that can definitely be reduced. Now the idea is you want to try to find the perfect square, the largest perfect square that is divisible into that number. So let's do X equals the square root of 36 times the square root of 2. So we get X equals 6, radical 2. So that's your final answer for number 2. That's the geometric mean between 9 and 8. Now let's do number 3. Let's do 27 divided by X equals X divided by 3. We'll cross multiply. X squared equals 81. Take the square root of both sides. And luckily, 81 is a perfect square. So we get x equals the square root of 81, x equals 9. That is your final answer. All right, so let's go on to the next page. So I want you guys to spend a couple minutes, or not a couple minutes, spend a little bit of time reading this theorem. I want you to try to digest the words and see if it makes sense. So it says, when an altitude is drawn from the right angle of a right triangle, two smaller right triangles are created, and all three triangles are similar. So I think you guys notice the large right triangle. We have the large right triangle right here. And then the segment CD which is perpendicular to segment AB, that's the altitude. So the altitude is the green line that's created, that's CD. So when you draw an altitude in a right triangle, you create two smaller triangles that are also similar to the third one. So what we're going to do is we're going to write a similarity statement for all three right triangles. And the idea is we're going to separate the triangles into the big one, the medium one, and the small one. So if we have the large triangle, and I drag that over here, then I draw the medium-sized triangle, and drag that over here. And I finally draw the small triangle. And I drag that over here. Those are your three triangles that are going to be similar. Now, the important thing is to label the right angle so you know where everything is. And the large one, that's the right angle. The medium one, that's the right angle. And the small one, that's the right angle. Now, it may be difficult to figure out which letter to put in the triangles. So actually, let me label triangles first. So this is A, this is B, this is C. This is A, this is B, this is C. And this is B, this is B, this is C. So a helpful way to write the similarity statement is to come up with two numbers, let one of them be smaller than the other, and put those numbers in your large right triangle. So let's say this angle is 30, let's say this angle is 60. Now, when we're comparing all the triangles, the large triangle and the middle triangle, they share angle A. So this is also going to be 30 degrees. And the large triangle and the small triangle, they share angle B. So that's going to be 60 degrees. So now we can label the other angles. This will be 60. This will be 30. Now the idea is let's label the triangles in order from smallest to largest. So we'll do the 30-degree angle, the 60-degree angle, and the 90-degree angle. So in the large one, if you go 30, 60, 90, you have A, B, C. And the middle triangle will have A, C, B. And the small triangle will have C, B, and D. So there's your similarity statement for all three triangles.